you should have an understanding of why the transition needs to happen and how it's happening. Again, solar, it's inevitable. It's coming your way. It's already happening and you cannot avoid it. So you might as well just do it yourself and get all the benefits. How does traditional energy work today? You have the utility. They have to collect the raw materials, whether it's fossil fuels, nuclear, hydro, oil, whatever it is, gas, to produce that energy. Then they will take that, they generate that electricity, they take that to a substation or transfer station, and then they will drag it across the distribution grid, the power lines, hundreds of miles, and until it gets to the point of consumption, which is your home or business. So that journey is very inefficient. You're paying for them to essentially take the power to you, to the point of consumption. And you're paying taxes, fees, surcharges, all kinds of different things associated with being able to take the value, which is the generation, to your home because you're far away. So you're gonna get rid of all the inefficiencies when you go solar. It's local, it's on top of the house. We're gonna explain how that works in a second. Just be mindful, look at your bill, and I invite you to look at your bill and look at how much you're paying for the actual generation of power, and the rest, it's just add-ons. And guess what? You need to be aware that you can generate your own power on top of your house. So let's talk about how this works, all right? Solar Energy Basics 101. So you have the solar panels on top of the house or the roof, right? Or it could be ground mounted, all right? So you have that picture there, but anyway, we'll just go over this, for a second, all right? You have this, boom, you have a house, etc. Something like that. And you have the solar panels here, boom, boom, boom. I'm not a good artist. Anyhow, they are going to absorb sunlight. You're gonna hit the sunlight. That is going to be converted to DC energy. That is direct current, okay? That's typically what we have in batteries and cell phones and all those things, but that's not what we typically use, okay, in the household. We use AC power. So how do we get from DC to AC? We need a device called an inverter, okay? So that's connected, let's say the inverter's here, all right? Or you have microinverters of different kinds. You have the string inverters and you have the microinverters. If it's for a house, you should be considering microinverters. In my opinion, they're better serving you than the string inverters, okay? Why? Because you have the ability to just be independent. Every single panel is independent from the other. So if one fails, it's not gonna affect the rest of the system. It's gonna be bypassed. So we do suggest microinverters for residential applications. For commercial, we actually lean more towards the centralized or string inverters for that description. Now, you have also the electrical box, right? You have the electrical box on that house. So once you change from DC to AC to the microinverter, you're gonna go into the electrical box, okay? And that box is connected also to a meter, okay? That meters, you can go here, and that meter today from the utility, it's a one directional meter, the utility meter. Why? Because it only has one power source. But when we go solar, the utility has to come out and swap that to a bi-directional one. So now it's gonna go in and also out. Why? Because you have two power sources. You have the sun and you have the utility, and we're going to be trading power with the utility. I'm gonna show you how that's done. So we produce power, and then at night, we don't have any sun. So we consume during the day and we consume at night as well. Throughout the day, you're producing enough power for the consumption. And then any excess that you use, you'll actually export it into the grid. That meter starts running backwards, and they give you credits for that. So that at night, when there's no sun, you're gonna just pull from the utility like normally you wouldn't, right? And you're actually consuming those credits. Those credits right now in South Florida, for the most part, okay, for the most part, not every single utility, you will be able to trade at a 1-to-1 rate. This is called net energy metering, okay, or net metering. It's the ability to trade power with the utility at a rate. Most utilities down here still have 1-to-1. Every single kilowatt hour or unit of energy that you have, you'll get back at the same rate. So it's a good business, you know, to trade power with them. They obviously have a minimum charge. Typically it's 25 bucks or 30 bucks for Duke. And that's just to trade power with them. These are consumable fees as well. So you'll be able to trade power with them throughout the day and night. Those credits typically roll over month, but not year over year. That means at the end of the year, they wipe them out and you start from scratch again. Again, this is called net energy metering. It is one of the points that it's a sense of urgency for everyone that's trying to go solar. Why? Because it will go away, or it will be reduced at some point. They have already tried to do it multiple times. And guess what? If that happens, automatically, you will need to have solar with batteries so that you're not losing the value of every single unit of energy or kilowatt hour that you're producing. So right now, you get to trade power at a 1-to-1. Typically, the utilities have a contract for 20 years where you can trade at this 1-to-1 rate. So go solar as soon as possible, because if that changes, you need batteries. Now the investment could double or just be a lot more than what you would expected it to be. Okay?